Hello everyone. So in this session, we are going to discuss master node component. So in the last session, we have seen Kubernetes architecture. What is a master node? What is a worker node? And master node contain what component? Worker node contain what component? Now we are going to discuss what master node contain the component, and we will discuss in more detail master node component. Okay, let's now first we discuss what is a cluster. So cluster is nothing we can say is a set of nodes grouped together. So cluster is nothing group of machine, a group of server that you can group together. So this way, even if one node fails, suppose you have your application is still accessible from other nodes. So what the advantage of cluster? Suppose if any one of the machine is fail, still you are able to access your application from other machine. So moreover, having multiple nodes actually helps in sharing load as well as. So to manage actually cluster, what we are required, guys? We require one master. So what is the role of master? So work of master. Master basically actually to store the information about the member of the cluster. So in the cluster, we have worker node and master node. So master node contains the information about all the worker node. It will monitor all the nodes also. Master node also monitor the node. If any node is not working, yes, no, any node is unhealthy, so it will monitor also. And it will move the workload of the failed node to another workload. Suppose if any node is failed, so it helps to move the workload of the failed node to another worker node. So master is another node with Kubernetes installed in, and it is a configured as a master. Actually, master is also one node, but we have configured as a master. It means that will monitor all the node in your cluster. So master watches over the node in the cluster and is responsible for the actual orchestration of Kubernetes on the worker node. So master node basically responsible for actual orchestration. Actual orchestration means management of container on the worker node. So where container is running on the worker node. So master node will take care, yes, not to manage those containers which are running on the worker node. So when installing the Kubernetes on your system, actually installing the following component. In the Kubernetes, once you install in your machine, so master node will be installed. Along with master node contains these are components. So this component also will be available. So master node contains which component? API server, scheduler, control manager, and etcd. So let's first we understand API server. And you can check this diagram also. If you check this, the master node contains these are components: API server, scheduler, control manager, and etcd. So let's understand first of all API server. What is the use of API server? Actually, API server basically act as a front end for Kubernetes. So API server will take our request. So whenever any client make a request to access your Kubernetes container, yes, no, that are running in Kubernetes cluster, so user request will be handled by the API server. API server will handle the request, and then API server will redirect the request to the appropriate worker node. So API server will take our request. So I want to deploy suppose my application in the Kubernetes by using web dashboard using, or yeah, you can use kubectl. So I will tell to the Kubernetes, hey Kubernetes, deploy my application. So this the Docker image of an application. Please deploy that application in Kubernetes. So when you will send a request to the control plane, inside the control plane there is a component. It's called a API server. So API server, what does, guys? It will receive incoming request and it will store that request information into the etcd. You can check here. Etcd is a one more folder here, the component. So whenever client anyone make a request to access, yes, no, Kubernetes, so request will be handled by the API server. So API server acts as a front end which is responsible to receiving all the incoming requests in your Kubernetes cluster. So whatever, yes, no, request is coming in your Kubernetes cluster, those requests will be handled, yes or no, by the API server. So API server, in simple term we can say API server will receive incoming request and it will store that incoming request information into etcd. So it means each API, yes, each incoming request information, it will store also in etcd. So what is the etcd? Etcd is a Kubernetes cluster database, we can say. Etcd is nothing. Etcd is just like a database. So it is a Kubernetes cluster database. So etcd is a distributed reliable key value store, key value database. It will store the information in the form of key value pair. And etc is a distributed reliable key value store used by Kubernetes to store all data used to manage the cluster. So consider when user have multiple node and multiple master in their cluster, etc store all that information on all the node in the cluster in distributed manner. So etcd acts as an internal database also. Etcd acts as an internal database. So it acts as an internal database also. So etcd acts as an internal database for the Kubernetes cluster, which is used to store the request information, what request we have sent to the Kubernetes cluster. So whenever you send a request to the Kubernetes cluster, API server will handle that request, and after handling that request, API server will store that request information inside etcd. So etcd acts as an internal database for Kubernetes architecture, which stores the request information, what request we have sent to the Kubernetes cluster. So what request received by the API server, all the request information will be maintained in one database in the Kubernetes that is called etcd. So when you deploy my application, API server receive my request and it stored that request into etcd database. Once that is stored in the etcd database, then scheduler will come into the picture. Okay, now understand guys, next component. Actually, suppose whenever any user make a request to access your Kubernetes cluster, so now request will be handled by the API server. API server is the part of the master node and it will handle, receive the incoming request, and after that it will store that incoming request information inside etcd. Okay, now your container running in multiple worker node. Now request needs to redirect it to which worker node. So who will decide? Then actually, then which come into the picture, next component, scheduler. So scheduler actually is responsible to schedule the pending tasks that are available in the etcd. So scheduler will check pending tasks in the etcd. It will schedule those tasks in worker node. So whenever suppose anyone make a request to access, yes, no, containerized application that are working, that are running in your Kubernetes cluster. So now request will be handled by the API server. That request information will be stored into the etcd. Then scheduler will check that request information and then will decide and send the request appropriate worker node where container is running. So who will schedule the task? Who will schedule? Scheduler. So whatever the request come, that will go to the API server. When you make a request, request go to the API server. So API server will store in the etc that request information. So API server will store that request information into etcd. Then scheduler come into the picture and it will check what are the pending tasks available in the etcd. Then it will take those pending tasks and it will schedule the pending tasks to the worker node. So scheduler will check pending tasks in the etcd and it will schedule those tasks in worker node. So suppose guys, I want to deploy my application. That task is still in pending. So it is available where? In etcd. So then scheduler come into the picture. Then it will check any pending task in the etcd. Then it will schedule those tasks in the worker node. So while you scheduling the task, it will check how many worker nodes are available, how many are up and running. Suppose there are suppose two worker nodes are available. So which worker node is free? Simply it gives requirement to that worker node. So here you can check here, there are three components we have discussed here first. One is the component that is a API server, second one is a etcd, then third one is a scheduler. So in simple terms, we can understand whenever any client make a request to access your Kubernetes cluster, incoming request will be handled by the API server. After handling the request by the API server will store that incoming request information into etcd. etcd acts as an internal database for your Kubernetes. And now then scheduler come into the picture. Scheduler will scan the database and will check out any pending task is available. If any pending task is available, then scheduler will schedule and will redirect that request into the appropriate worker node. It will scan everything. It will check, yes, no, how many worker node is available, how many worker node is up, yes, no, and which worker node is available to accept the request. So based on that, it will schedule the job. So these are three components: API server, worker node, API server, etcd, and scheduler. Now we have one more component, that is a controller manager, guys. So controller manager actually we can call as a brain behind orchestration. Actually, this controller manager basically responsible for noticing and responding when node, a container, or endpoints go down. Suppose if any node, a container goes down, so who will take care? Controller manager will monitor. Let's understand this scenario. Suppose guys, you have created one Kubernetes cluster architecture. In that architecture, suppose there are two worker nodes. Yes or no? So you have created cluster with desired capacity. Desired capacity is a 2. So there might be chance any worker node can goes down. So control manager is responsible to take care, yes, no, whatever desired capacity you have specified, that desired capacity needs to maintain the entire life cycle. Suppose if any worker node goes down, immediately it needs to take care and will need to set up new worker node. Yes, no. Yeah, any container is goes down, yes, no, it needs to take care, it needs to set up new container. So who will take care that Kubernetes architecture? In Kubernetes architecture needs to take care by controller manager. So controller manager is responsible for noticing and responding when nodes, a container, or endpoints goes down. Container make decision to bring up new container in such cases. In such cases, yes, no, container take decision to bring up new container. So controller manager is a very important component. Basically, in simple terms, we can say controller manager basically manage your Kubernetes cluster architecture. How many worker node is required? Yes, no. So controller manager basically will monitor all Kubernetes resource functionality. In very simple terms, we can say what is the role of the Kubernetes controller manager? Controller manager will monitor all Kubernetes resource functionality. So all resources, yes, no, that are available in Kubernetes cluster are, yes, no. So those resources will be monitored by the controller manager. So these are four components that are available in master node that we have discussed. Which one? API server, scheduler, etcd, and controller manager. Let's we recap in one word. What is the role of the API server? API server is responsible for handling all incoming requests. So after handling the incoming request, it will save that request information into etcd. So etcd is nothing. It acts as an internal database for Kubernetes, which store information in the form of key and value pair. And then scheduler comes into the picture. Scheduler will scan etcd database and it will check if any pending task is available. So it will check and it will perform those pending tasks on worker node. And now controller manager. Controller manager basically responsible to monitor all the Kubernetes resource functionality. So I hope it's clear. Yes, no, component of master node. Thank you, everyone.